please welcome your host, Sean Heisler.
Hello, everyone, and welcome to the first ever Shell International Engineering Competition. This is one of Beakerhead's flagship events, and all of you are here to witness its final moments. Beakerhead smashes things together to make brand new things, and the Shell International Engineering Competition does exactly that. On one hand, we have American Idol. On the other, we have one of the toughest, most demanding exams you have ever taken. We bring them together, and that is what you're going to witness. This event has never been done before. We have 15 teams, young, creative engineers. They've come from all across Canada, the US, and all over Europe to compete here. It is an absolutely amazing thing to be a part of. Let's give them all a hand. So we've got two competitions for you to watch here. Design, 8 teams did that. And then we have consulting, the other 7 did that one. The top 3 of each competition have made it through to this finale and are here for the final judging. They have sweated through 24 hours of competition to figure out what they needed to do, how they were going to do it, and then to actually get her done. It's first prize and a cash prize at stake. Here's how it's going to go tonight. Each team is going to have 2 minutes to present their design, a summary for all of you. Then the judges have 1 minute to quiz them. After a short deliberation period, all of our winners will be announced. Are we ready to get the competition started? We'll lead off with the consulting competition. Each consulting team has been challenged to figure out a plan for the future storage, recycling, and disposal of these giant haul truck tires that they use up in the oil sands. Their plan must take into account logistics, costs, and especially the environmental, social, and economic impacts of their solution. I mean, these tires in question are way taller than me, and right now there are hundreds of them accumulating every year in Alberta. It is a real-world problem that was brought to us by Sid Nag from Shell, and companies all across the province are facing this. So it's not a pretend problem. These teams are designing real solutions. They only had 1 day, though. Only 1 day to analyze field data, create an innovative solution, and propose their plan of action. 17 started the consulting competition yesterday, and we've got 3 remaining. Which team will impress the judges with their technical brilliance and presentation prowess? We're going to find out. Let me introduce our expert judges for the consulting competition. From Penn West Exploration, we have Majid Saidi. He is a UFC graduate, and he's currently working as a reservoir engineer. From Engineers Canada, we have Marc Bourgeois. He is the Director of Communications and Public Affairs, and an honorary fellow of Engineers Canada. And lastly, from Shell International UK, we have Stephen Goodchild. He's worked all over the world and is a current VP with Shell. Before we bring out our first team in the competition, I do have one special announcement that the judges would like to make. One team did not qualify, but they wanted to give the team a very special mention. We had a team from Romania compete, and only half of their team was able to make it to the competition, as we had some unfortunate visa issues. But the team finished the problem presented and were fantastic, and the judges wanted to give a special hand to that team. Now let's welcome our first team, consulting team number 1, from the University of Alberta, the Golden Gears.
We are the University of Alberta Golden Gears, representing the University of Alberta in Edmonton, Alberta. Our goal today is obviously to do really well in the competition and produce a report and a presentation that we're proud of and we think addresses the solution and the problem in the best manner possible. And obviously it is a bit of our goal to win as well. Best part of our team is I get to be able to compete with my best friends, and at the world stage it's pretty amazing to meet teams from all over the world and think that we all know each other from high school and then university together. Our team is going to win because we are really diverse in our backgrounds. We have industry represented, we have research backgrounds, so really we can bring different perspectives to the problem and create a solution that's comprehensive.
Are you ready, University of Alberta? Your 2 minutes of presentation time starts in 3, 2, 1. Take it away.
Good afternoon, everybody. My name is Alex Grams. These are my friends and colleagues, Nancy Manchak, Garrett Clark, and Michelle Hauer. Together, we're the Golden Gears consulting team from the University of Alberta. Yesterday, when confronted with this challenge, we brainstormed and considered a number of different options based on the recycling, disposal, or storage of these tires. Eventually, through a decision matrix, we decided upon the choosing of a recycling solution which produces rubber crumbs from these tires.
For our engineering technical solution, we developed a six-stage process that is able to take waste tires seen in the Athabasca oil sands into usable rubber products. With this, we had shredding stages as well as magnetic separation stages. Ultimately, we're able to make a product of rubber that can be sold back in near original form of rubber and as rubber crumb using a devulcanization process.
We also identified a number of revenue streams that could be associated with our proposal. These included using rubber crumbs in the production of rubberized asphalt, using rubber crumbs as a new and innovative type of pipeline bedding material, using the devulcanized rubber as a raw resource to sell on the market, and using the scrap steel that we produced to sell that to local steel mills.
We also took into account some environmental and social factors. So specifically, we located the processing plant in the Fort McMurray area, and that was to reduce transportation of the actual tires in their original form. This reduces the social impact of having wide loads and trucking on busy highways, as well as allowing some more versatile transportation options, which could be more environmentally friendly, for example, rail instead of trucking. We also looked at recycling tires that are in the community, actual consumer car tires, as another possibility.
Thank you, team number 1 from the University of Alberta. Judges, it's your time to shine. You've got 1 minute for questions, starting now.
What would you wish to accomplish as a consultant via your proposal?
I think it's very important that while you're developing a solution, that you take into account the community aspect and coming up with something that's viable and sustainable to try and build the PR image of the company that's dealing with this problem. And while solving the issue of getting rid of the tires, you're helping to build a better community.
Another one. Who are your key stakeholders and how do you propose to manage them in implementing your project?
One of our key stakeholders is the hypothetical oil company Saturnica, who we actually have our site constructed at their existing mine facility. With this, we're able to tie into existing infrastructure for electricity demands and other utilities. However, we're providing an example for industry. This tire solution is applicable to other partners and companies in the oil sands region.
Up next in our consulting competition, we have our second team, JTAC Consulting, from Canada, hailing from the University of British Columbia.
So we're JTAC Consulting from the University of British Columbia in Vancouver, Canada. The team dynamics are awesome. We're a team we've worked together a little bit before, and so we're quick, we get along well, and we can sort of work on stuff, come back together, and really move forward quickly. The best part about our team is I think how broad we are. We're all in different faculties, we have different job experiences, and we definitely can see problems from a lot of different angles, which helps. Our team's going to win because we're not jet lagged. I think that's a big part of it. We're prepared. It's an area we know. The oil sands are right next door to BC, so we're pretty familiar with it. And yeah, lots of sort of background knowledge. The one thing we wish we could use is some of our industry contacts. It's sort of tough seeing problems, knowing just the guy to call, and not really fair to the other teams, but that's a little challenging, wanting to use those, not being able to. I think just seeing all these people here, it's a cool festival for sure.
JTAC, are you ready to start your presentation? Take it away in 3, 2, 1, go.
Hello everyone, we are JTAC Consulting from the University of British Columbia. So we were tasked with getting rid of a very large number of very large tires by reducing, reusing, or recycling them in some way. Turns out we can reuse and recycle the tires pretty effectively by grinding them up and turning them into a road, which is also handy because we can put cars on top of that road. But we wanted to take a step further and hit that most important R, reduce. And we propose to do that by paving the major roads at the mine sites themselves, saving both on fuel as well as, most importantly, extending the tire life and reducing the number of tires that are wasted.
So basically, to reiterate our plan, we want to take the existing stockpiles of tires, grind them up, and then put them on what are probably pretty rough roads. Once we put this on, we'll have nice smooth asphalt, which really increases our tire life. We ran some numbers, and we found that over the life, it can probably save about $500 million for a 25-year mine life.
So how we came up with that number is we figured that we could save about $3 million per year per truck based on the reductions in downtime losses, based on the fact that we could improve utilization of the trucks by about 0.7% and keep the trucks out of the maintenance shop and on the road mining.
Thank you, Kevin. So we were looking for a made in Fort McMurray, stays in Fort McMurray solution. We also recognize the importance of having strong industry partners, so we've identified a number of local businesses in Fort McMurray, including a tire shredding company owned by an Aboriginal group to help get this project started. There is also extensive research that shows that using tires as asphalt on roads is safe for us and the environment. So to conclude, we have addressed the problem of too many tires by looking at the 3 R's of sustainability: reduce, reuse, recycle, and we have saved the mine money.
Great work, UBC team. Judges, it's your time to grill the team. You have 1 minute starting now.
Okay, so first off, same question. In addition to satisfying the technical objectives, disposing of the tires, what would you wish to accomplish as a consultant via your proposal?
Sure, so we would of course look to make sure that we are hitting our 3 R's. That was the most critical part for our group. Instead of just recycling the tires and putting them in a scrap dealer, we wanted to make sure that we were fundamentally reducing the tire output. So this both meets the client's needs as well as directly addresses the community needs as well.
Can you describe the roads for the audience, and also how would you resolve the issues that would come around in building roads out of tires?
So there's a couple of issues with that, and one thing we were really lucky with is that the existing haul roads act as a phenomenal subgrade to pave over. We have to use a lot of asphalt to be able to meet the heavy weights of the loaded haul trucks. But the rubberized asphalt is proven in a lot of environments, especially in cold environments where you get a lot of anti-skid properties.
We'll round out our top 3 consulting teams with the third team, Maxwell's Equations from Italy, Politecnico di Milan.
We're from the Politecnico of Milan in Italy, and we are the Maxwell's Equations team. Maybe the most challenging thing is always to face a topic we don't know much about and trying to make the best use of our education to overcome the obstacles in resolving the problem. The best part about our team is that we are friends before we are teammates. So we really enjoy working together, and finding the solution is quite as exciting as going out together. I think that a reason because our team may be the winner is that our technical knowledge is really a top-level one. Oh, the most exciting part is surely the international knowledge you can make just by meeting the other members. After the competition is over, we're really looking forward to party with the other teams because that's the best part of this competition.
Team from Italy, are you ready? Your presentation of 2 minutes starts in 3, 2, 1, go.
Good afternoon to everyone. We are Maxwell's Equation team from Italy. I'm Jacopo, is Matteo, Andrea, and Giorgio, and we are proud to present to you our solution of the proposed case study.
Our project involves a very big initial investment to build 2 brand new facilities. One for retreading the consumed tires in order to drastically cut down the costs for the supply of the tires, which are really huge. Then we did a tire processing facility whose main job is to get rid of all the volume the tires occupied. So we end up with no tires and 2 possible sources of income. Here is a detailed structure of our project. Systematic maintenance helps the standard operation run smoother with longer lifetimes for the tires and so lesser costs. Retreading and tires processing can be used as sources of income because retreading can be done also for third-party companies who have similar needs to ours, and tires processing outputs products that can be used in a variety of industries listed below that will pay us for providing them the products. For reaching this objective, we studied the management of the project.
Okay, we'll set up a roadmap to accomplish all the tasks, the main task of this project. And we also set up a team that will supervise this entire project, and team from up to 15 people, 15 engineers probably like us. And we set up even 3 milestones for the main important things, and I will give you the...
Yeah, we also care for sustainability, and we managed to show that our project is economically feasible. Actually, it's highly profitable. It's socially sustainable because it's going to create new jobs in the area of Edmonton, and it's also environmentally feasible because it has no direct pollutant emissions. Thank you very much.
Thank you, team number 3. Judges, it is your last opportunity to grill the teams. Take it away for 1 minute.
So again, we'll begin with the same question. In addition to satisfying the objectives, disposing of the tires, what else would you wish to accomplish as a consultant with this proposal?
A big concern right now all over the world is to face the lack of energy sources. And retreading is a way to save a lot of fuel, up to 70% actually, in making the tires. So we think that finding a way to include something that helps dealing with problems that are over the top of everyone's, no one can do alone something to fight against these problems, but managing to do something that impacts on these issues is great.
Okay, thank you.
Okay. Another question. So you have proposed to transport the tires to Edmonton for processing. There is no railway between Fort Mac and Edmonton. How do you propose, or what are the challenges that you have to take for this transportation between the oil back and forth between the oil sand mine and Edmonton?
Transporting these tires is a terrible problem, and so I think that probably the most feasible possibility is to make so that in the same facility that treats the degraded tires, you can have also a substitution of those tires, so that you can bring the used tires at the facility with the same trucks that has the tires.
Thank you, final consulting team. I found the solutions incredibly interesting and all very different, which was exciting to see. Judges, it's time to deliberate. Please head to the deliberation room and enjoy your tough decision. While we wait for the judges to deliberate, let me welcome a special guest, an astronaut with 3 spacewalks under his belt while on board the Endeavour. Everyone, please give a warm welcome to Commander John Harrington.
Good afternoon. How's everybody doing? This is fabulous. This is a lot of fun. I've had a fabulous time here in Calgary. I'm from Lewiston, Idaho. I'm also from a little place in Oklahoma called Shawnee, Oklahoma. And I've had a chance to be here at Beakerhead for the past few days, and I've had a chance to speak to a lot of students at a lot of the reserve schools around here. My heritage is Chickasaw Indian. I was considered the first Native American or Aboriginal astronaut in space, and so it's an honor for me to come up here to Calgary and to be a part of this fabulous time at Beakerhead. Really quick, my background, I'm really from Oklahoma. I'm a member of the Chickasaw Nation. I moved around a lot as a kid. By the time I graduated from high school, I think I moved about 14 times. When I went to high school, or went to college, my parents said, you have to go to college, because if you improve your chances for success, you need to go to college. But I didn't know what to study. I didn't have a mentor or motivator. I decided to be a forest ranger. I didn't do very well. I spent most of my time in the mountains rock climbing. And you don't study, you don't pass your classes, you don't stay in school. I was suspended my very first year for low grades because I wasn't motivated. I was fortunate to go to work for an engineering firm as a rock climber hanging off a cliff, and the gentleman I worked for, and I saw math in practice. I saw math being used in a practical application. It was the first time the light came on. And I had a gentleman that convinced me to go back to school and be an engineer. I graduated later on in 1983, and a gentleman I tutored in calculus was a Navy pilot, and he convinced me to join the Navy. And so I flew airplanes in the Navy for 22 years, and 9 of those I spent at NASA, and had a chance to fly in space and do 3 spacewalks. And that's a story all in of itself. It was a fabulous experience. But if it hadn't been for people that made a difference in my life, I would not have had a chance to do it. Since I left NASA, I've been involved in engineering competitions and judging competitions. And one of the things that I find in judging these things is that when you give a task to a group of people, it's all about engineering. It's okay, you have a task to accomplish, you have a very small budget to do it with, and you have a very short time to accomplish it. And you set the team off to do that and to see if the team can accomplish the task that you put out before them. And what amazes me is what the talent that exists out there in the university system and in the high school system as well, that kids can come up and students come up with these remarkable solutions to problems that are placed in their lap very early on. So that's engineering at its finest. And to be a judge, to participate in that and to see students do this remarkable thing is really, it's an honor. And it gives you really great hope for the future that there's really talented people out there that can make the solutions that are going to make our lives better. And one of the parts about flying in space is that you don't do it by yourself. You do it with a team. You do it with a lot of people, because if it wasn't for all the people, and I was told this once by a gentleman named Jerry Ross, and Jerry Ross flew in space 7 times. He's walked in space more time, many, many times, one of the record holders for it. And he said that you're there flying in space because you're standing on the shoulders of all the people that made it possible. And so all of the engineers that made it possible for me to fly in space, I am so fortunate that they worked so hard to come up with solutions to fly vehicles in space and get humans in space. So what the students are doing here today and the challenges they've been presented in a very short period of time, that's what engineering is all about, and that's what these competitions are about. And I am so thankful you're here to participate, to watch what they're doing, and to congratulate them as they go through this process. So I'm honored to be here tonight. If you guys see me around in the blue jacket, I'm happy to answer any questions about flying in space. But Beakerhead's been great. Thank you very much for being here.
I think in that time, our judges have had just enough time to deliberate, and they're ready to come back out. So, before we get them though, let's welcome back all of our consulting competitors to the stage. And it looks like our consulting judges are just about ready. Let's give them a warm welcome back to the stage with their verdict. So joining our consulting judges on the stage, we have Michael Ross, who is the designer of the competition and the manager of this consulting competition. So let's give him a warm thank you. Judges, do you have a verdict for me? In second place, we have our team from Italy. And the team in consulting that takes home all the marbles, our first place team, Team JTAC from UBC. Let's give a big round of applause for our third place team. Second place team, let's give a very big round of applause. And finally, one last round of applause for our first place team from UBC. A big thank you to all of our consulting judges and consulting competitors. That marks the end of that competition. With that, it now marks time for the top 3 of our other competition, the design competition to strut their stuff. All of our design teams were challenged to turn 2 fairly ordinary sets of objects, a piano and a set of pool balls, into a calculator of all things. It needed to accept numerical inputs from the piano, find some way to do the math you just asked it for, and then present the answer using pool balls to display which number the result was. The teams had limited tools, limited materials, and only 24 hours to finish their invention and their presentation. It is really a very Beakerhead challenge, bringing 2 very different things together. Let's meet our expert judges for this competition. From the University of Alberta, we have John Nijka. John is a materials engineer. He's an associate professor and associate chair at the University of Alberta Engineering School. From SNC-Lavalin, we have Martin Humphreys. He is the Vice President Engineering at SNC-Lavalin and has come over to Calgary this year after 30 years of worldwide experience. From PricewaterhouseCoopers, we have Darshni Pillai. She's a former co-chair of her school's solar team when she was an engineering student and is no stranger to competition. From MDA Space Missions, we have Natalie Panic. Natalie has worked on in-orbit satellite servicing, and she's now a robotic operator and aerospace engineer at MDA Space Missions. And our final judge, Ms. Stacy Rector. Stacy is from Shell Canada, and her career began as a student intern. She's since moved through reservoir engineering to her current position as a production engineer. Let's welcome our first design competition team. Team number 1, the AAA Alberta Tenderloins from the University of Calgary here in Canada.
We are the AAA Alberta Tenderloins with the University of Calgary. One of the big challenges is doing the arithmetic and the mathematical operations with very, very basic tools. We either have to have a mechanical solution or we can only use simple logic gates. That's going to be a big challenge for us. We're a really well-rounded team and we can tackle any challenge that comes to us. We only have 13 hours to build, so we have to really take into account our time frame. Although it's bigger than some of the competitions, more time than some of the other competitions, we're under the gun. We're gonna win because we work together well, we have a well-rounded team, and I think that we have a lot of experience in this type of competition. We're here to compete, but as long as we get free food, we're all winners.
Well, let's hope you can wrangle more than free food in this one. Are you ready to start your presentation?
Yes, we are.
Take it away in 3, 2, 1, go.
Thank you, Sean. My name is Michael Pacenti, and I have the great pleasure of introducing the rest of the University of Calgary Quartet. With me today, I have Riley Booth, Adam Yurchenko, and Paul Coyle. When we saw the problem yesterday, we realized it wouldn't be a black and white issue. As we pitch our design to you, we'd like you to keep in mind that this isn't just something we played by ear.
All right. Our mechanical design aimed to be very minimalistic. We wanted to interfere with the piano as minorly as possible. So, in our final solution, we had major simplifications to the other possible design choices that we considered. The real forte of this design for the mechanical dispensing of the billiard balls is that it uses only a duet of small motors.
The idea of maintaining the playability of the piano while also performing the functions of a calculator was something that really struck a chord with our group. And we felt that being able to conduct a symphony between art and engineering is something that Beakerhead in this competition was about.
So harmonizing with the mechanical aspect is the electrical aspect. Our team repeatedly tuned our design to make use of the scarce number of parts we had available. That included creating one addition circuit and using that to perform all of our mathematical operations. The mathematical unit was also really easy to extend and thus would allow us to add a chorus of other operations should we so desire later. Thanks very much.
Thank you, Tenderloins. Judges, you've now got 1 minute for questions. Take it away.
I noticed that there are only 3 women in this competition. If you had a woman on your team, do you think it would have given you an edge?
I definitely think so. We tend to get a little unruly, so we need someone to keep us in check. But no, you're absolutely right. I mean, I think equality across the disciplines is absolutely necessary. And I think that would give us another aspect that we probably didn't have. So you're absolutely right.
Has innovation been prevalent in your education, and how can we encourage more innovation in the education system?
I think that nowadays we're really trying to strive for innovation. That's a pretty big buzzword. Schools are always trying to talk to people in industry. How can we teach our students innovation rather than just technical knowledge? They got to be able to think outside the box, and that is something that is definitely stressed in not all of our courses, but in our design courses.
Great job. Next up in our design competition, we have a team hailing from fairly far away, all the way from Sweden, team number C, from the Royal Institute of Technology.
My team name is Team C. We are from 2 different universities in Sweden, from the Royal Institute of Technology in Stockholm and from Linköping University. Our goal is to have a lot of fun and just try to enjoy our time here and try to win. I think we didn't prepare very much to come here. We barely knew where to stay the first night, but we prepared as much as we could. We asked questions to the organizers and tried to know as much as possible about the competition. But other than that, I think we just took it as an adventure to come here. I think it's always the most exciting in the beginning when we get to come up with ideas and have all the different things to think about. Of course, you get stuck somewhere, but then it's also exciting when you get an idea that you actually think will work.
Design team from Sweden, are you ready for your presentation? Take it away in 3, 2, 1, go ahead.
Thank you very much. So first of all, we would like to highlight the key features of our design. Our design is fully mechanical, which means that we have no electric parts at all. We use only simple physics. We had we used very cheap materials. In fact, we were the team with the cheapest construction of all. Our calculator can perform addition and subtraction, and we have a very overviewable design, so you can always see what's going on inside.
Okay, so now to a brief overview of how this piano calculator functions. So, the core aspect of this is this soda can. It's not something you just left here. This is the most important part. And it works by sliding in this direction when this wheel rotates clockwise, and it slides in the other direction when this wheel goes counterclockwise. And how do we make the wheel turn? To do this, we have these pipes, 3 of them, one here, and 2 on the other side. And in these pipes, we have weights. And when the weight drops, it pulls on a string, which turns the wheel. So first, if we want to do 7 minus 3, for example, we first have one weight falls down 7 units, and we can decide how long it falls by using the keys here, which pulls these blockers and blocks the weight at that height. And then we can do the same thing, but on the other side, rotating either clockwise or counterclockwise, and when they end up with the can in the right position, indicating what is the output, and that's our answer to our calculation. Thank you.
Thank you, Team C. Judges, your opportunity to grill them one last time. Take it away for 1 minute.
Do you think competitions like these are important for inspiring the next generation of youth, and why?
I think they're very important because we need not just to learn things, but we need to inspire others to learn and to learn in a good way. Here you learn not only how to do things like mechanically, but also how to think before you do, so you get good results. And I think that's very important, and it inspires other people to do the same thing.
What is the one piece of advice you would give future competitors?
The one piece of advice we would give future competitors was really think about your solution. It took us 5 hours to just plan what we would build. Sure, we would build during the time we planned, but the final solution was only revealed after 5 hours. So really put your time into planning.
For sure. Let's see if your time in planning pays off when the results are announced. Thank you to our Swedish team. Our very last team in this competition finale is team number 3. Team RAOO, all the way from Romania, at Politehnica University.
So we're Team RAO from the Politehnica University, Timișoara, Romania. We all study architecture, and the first thing was calculator. I don't know how to make a calculator. It was, what do I do now? But after we talked a little about the ideas and how can we incorporate the knowledge that we know into this concept, we found a solution. It's more mechanical than electronical. So we think we found a sweet spot between both of them. We each know his specific role in the team, and we know how to communicate one to each other, and our ideas can evolve much faster than in other teams. I think this is why our team is better. We are proud of what we're doing, and hopefully we'll finish it and show it to you.
Final team, you're ready to present in 3, 2, 1. Take it away.
Hello, my name is Ovidiu, and this is my team, Andrei, Adi, and Radu. We studied architecture at the Politehnica University in Timișoara, and we represent Romania. First of all, I would like to say that we are honored to be here and are very excited to be in the finals. Okay, so our design, our main design approach respects the mechanism of the piano, and because of that, because of the piano, that's a very complex mechanical device, we wanted to make a solution that it's also mechanical, out of respect for the piano. And I think our biggest personal contribution to this solution is represented by the number sheets over here. These number sheets, I don't think that we invented it, but they are very good, helps us to make all of the operations. So we can divide, we can multiply, we can add, and we can subtract, and also we can tell if there's an error or if the output is bigger than 15. And those okay, so this also helps us to make many other operations, but that we didn't need in this competition, but it's very easy to implement other operations. And now my colleague Adi will make a short demonstration on how it works.
So besides addition, subtraction, multiplying, and division, we added a few more functions. And now this piano can also do square roots and can also square a number and also do factorial. And for demonstrating, I will do, for example, the square root of 9. So I will press here, function square root, here. Then on the table, I see I marked in red because the red are added after that. So I'll look for 9 and see which button I have to press. Press this button, and it should be 3.
AAO. Judges, are you ready to grill this very last team for 1 minute? Take it away.
What attributes did your team bring to the table that you used to your advantage to make it to the final 3?
I think that the diversity, you know, each team member has a different personality. So as you can see, he's the artist with the long hair. He's the engineer. He talked about square roots, the square, factorial, stuff like that. He mediates the relation between he and he because, you know, he's very technical. He's an artist. And believe it or not, I usually I'm the PR of the team, so I usually talk. So that's my role in the team.
Really enjoy your piano. Could you tell us a little bit about what you value about and what you learned from the competitions personally?
From this competition, it was very interesting at first because we could talk to a lot of students from North America, and I think this was the biggest values that we've learned, how they think and how they learn, how they approach a design. I think this was very important for us because it was the first time that we had the opportunity to talk to North American students. And this is the biggest advantage.
Canadian team. Judges, are you ready for your deliberations? Well, hurry over your deliberation chambers and let's see what comes out of them. Our top 3 teams in the design competition have presented their final pitches to the judges. They've faced the challenge, they've innovated, and they've invented. They have done their absolute best. Now, everything rests in the hands of those 5 judges. While we wait for our judges to deliberate, we have a couple of additional awards to present. The first of which is the Engineering Impact Award. This award will be presented to one consulting team, chosen by our delegate from Engineers Canada, to the team who has best demonstrated the societal, environmental, and political impacts of their solution. The team that can take their technical answer and best put it into context of society. All of our consulting teams are eligible for this award, not just the ones you've seen. Here to present the Engineering Impact Award, please welcome back Marc Bourgeois. And the winner of the Engineering Impact Award is Team Maxwell's Equations from Italy. It really was a phenomenal solution. Thank you so much. Up next, we have one more special award to present in this break, and that award is the Student's Choice Award. Throughout this competition, we had about 1,200 students in grades 6s to 9 all across Alberta come visit our competitors. And they toured all of the design booths in the hall. On their way out, those students could vote on which design was their favorite, be it the one they liked the solution the best, or the team that presented it the best, or maybe just the prettiest piano. It was all in the hands of those students. This award is very simply just given to the team that has the most votes. Helping to present this award is our very special guest, Commander John Harrington. And the winner of the Student's Choice Award is, from home turf, Team AAA Tenderloins from the University of Calgary. Congratulations. I think through the presentation here in the finale, there was pretty obvious charisma through that team with all of their musical puns. I think our design judges are just about ready to come back. And so let's please give them a very warm welcome as they return to the stage and hopefully have a verdict. So again, tailing our judges into the awards presentation, we have the director of our competition. In this case, it is Mr. Eric Pospisil, who joined us on the organizing committee from UBC. Let's give him a very warm round of applause for the competition he designed. I see a verdict envelope. Are you all finished? Could I please welcome all of our design teams back to the stage? They look nervous? I think they do. It's a good thing. In second place for the design competition, we have Team AAA Alberta Tenderloins from the University of Calgary. And in first place for the design competition, we have, hailing all the way from Romania, Team RAAO. Let's also give a very warm round of applause for our third place team from Sweden, Team C. Thank you, design competitors. Thank you, design judges. That marks the end of our design competition. We have one last award to present tonight, but before I get there, I'd like to take a moment just to thank all of our wonderful sponsors, without whom none of this would have been possible. A big thanks to our exclusive sponsor, Shell International, for having the faith in our competition and taking the first step in sponsoring the first Shell International Engineering Competition. Our thanks to Beakerhead for bringing the creative imagination to believe that all of this is possible in the first place. Thanks to the Canadian Federation of Engineering Students for bringing the expertise in organizing a competition like this. I'd like to thank our venue host, the Calgary Stampede for this amazing facility we've had to use. Thank you to Engineers Canada for their continued support of all engineering across this country, including our competition. Thank you to Cisco, who has provided the live streaming of tonight's finale worldwide so the teams at home can watch. Thank you to machinacorp.ca for the medals that our teams have received tonight, which were 3D printed, if you believe it. And with that, we have reached the last thing on our program. We have one final award to present, the pinnacle of the competition, the Shell International Innovation Award. To present this, please welcome back to the stage Shell production engineer, Ms. Stacy Rector.
Good evening, ladies and gentlemen. Thank you for joining us this evening at the Shell International Engineering Competition Grand Finale. It gives me great pride to be here tonight at judging what must be the most exciting engineering competition ever to grace the Canadian stage. Seeing these teams in action has been truly inspiring, and I'm honored to represent Shell Canada on such an occasion. At Shell, we believe that taking an innovative approach to our practices, processes, and technologies is what will help us evolve to meet future energy demands. That's why this competition is so important to us. It provides us an opportunity to inspire the next generation of leaders to problem solve in an innovative way. We are pleased to present an award tonight to the team that best represents the spirit of innovation. By true spirit, we mean this team embraced innovation in their behavior, activity, and overall work. This included everything from choosing an uncharted path to arrive at a solution, to encouraging the free flow of ideas between all team members. It was a tough competition to judge. The level of performance has been absolutely top-notch by all teams. But only one team can be the winner, so without further ado, the winner of the Shell International Innovation Award is Team RAAO from Romania. Congratulations on the very big double win, Team RAAO, and thank you to Shell for that award. And with that, I'd like to wrap things up by thanking all of our participants who competed in the competition, all of the judges who gave their time in helping to judge and mentor these students, all the volunteers who made an event like this possible, and especially to all of you, the audience, for coming out and seeing what we've done. Thank you. And with that, this marks the end of the first annual Shell International Engineering Competition.